Hello everyone. Today our lesson about chapter 5, wave particle duality. There are 4 points to prove that black body radiation, thermal emission and photoelectric effect, Compton effect, wave particle duality. First, we start with lesson 1, the black body radiation. From our previous study, we know that any body emits radiation, maybe light, thermal, and so on. Any body has ability to absorb, reflect, refract light with different ratio. Black body absorbs all the radiations with different wavelengths. Classical physicists deal with light as wave, which has features like refraction, reflection, diffraction, interference, and propagates in space with high speed equal 3 times 10 power 8 meter per second. Light. Visible light is a part of electromagnetic waves. As we show in figure, at the right side of electromagnetic waves there is a radio waves, which has long wavelengths. Wavelengths decreases until we reach left side at gamma ray, which has short wavelengths. We know from previous study in secondary 2, frequency and wavelengths is inversely relationship. So frequency at the right side low and increases until reach to left side at gamma ray. The range of visible light in frequencies red 4 times 10 power 14 Hz, violet 7 times 10 power 14 Hz. Black body is enclosed cavity which has a small hole. The inside of the cavity appears black because all of the radiations within the cavity remains trapped due to multiple reflections. The large part of the radiation is absorbed, while only a small part of it leaks out, which is called black body radiations. Black body, it is a body absorbs all the radiations with different wavelengths, which fail on it. Perfect absorber. And emits these radiations only. Perfect emitter. Planck's curve. Curve represents relation between intensity and wavelengths. As we show in figure, intensity tends to zero at high and low wavelengths. Intensity tends to maximum at certain value of wavelengths called maximum wavelengths. As temperature increases, intensity increases and wavelengths decreases. Planck's curve represents more than one body, as sun, lamp, earth. Sun at temperature 6000 Kelvin, wavelength 500 nanometer, radiation 40% of radiation, light as visible light, 50% as heat, like infrared ray. Lamp at temperature 3000 Kelvin, with wavelength 1000 nanometer, radiation 20% of this radiation as light, like visible light, 80% as heat, like infrared ray. Earth with wavelength 10,000 nanometer, radiation or radiation as heat, infrared ray. Classical physicists try to explain Planck's curve. They succeed to explain the right side from the curve, where, according to classical physics, as intensity increases, with frequency increases, at wavelength decreases. But in the left side, while intensity decreases at high frequency, short wavelengths, classical physics can't explain that. They failed to explain. Who can explain this? Quantum physics. As we show the structure of atom, negative electrons revolve around nucleus in fixed orbits until atom gains energy as thermal or heat energy. For example, when atom gains energy equal to joule, this amount let only the electrons in outer energy levels to transfer from its level to the higher level. That is occurs only when energy equals the differences between two energy levels, delta E. After a period of time, it returns back to its origin level and emits radiation with energy equal delta E, the differences between two energy levels. When the amount of gains energy very small, the energy emitted in the form of infrared ray. By increasing temperature, the heat energy increases. For example, when we increase temperature to 600 Kelvin, the electrons in the energy after the outermost energy levels begin to transfer from the origin levels to the higher energy levels and return back, emitting radiation in the visible light after a period of time, and so on. By increasing temperature to 1000 Kelvin, the emitting radiation lay in ultraviolet ray. So the energy not continuous, but it's quanta, called quantized photons. So the relation E equal NH nu, where E energy, H Planck's constant, nu frequency, N number of photons. So by increasing energy, the frequency increases, the number of photons decreases. Why number of photons decreases? By increasing energy. Because by increasing energy, it deals with the electrons in the inner energy levels, which nearest to the nucleus. So the number of electrons are very small. So the number of photons decreases by increasing energy. When we have two of torchlights, one of them small and the other is big, the small one gives a small intensity of light, which means small amount of photons, while the big one, big intensity of light, which means that has more number of photons. So intensity equivalent to the number of emitting photon. That is explain why the intensity at high frequency and low wavelengths has small intensity, which explains the left side of the Planck's curve. So quantum physics success to explain the left side of the Planck's curve, which the classical physics failed in it. Planck's interpretation for the black body radiation. Number 1, he proposed that radiation was made up of small units or packets of energy, each called quantum or photon of energy, where E equal h mu, where h is the Planck's constant and mu is the frequency. Number 2, the photons are produced due to the vibration of atoms of radiating body. Number 3, the energy of these vibrating atoms is not continuous, but quantized, discrete, or discontinuous in two levels. This energy levels takes values equal E energy equal NH mu. Number 4, the atom doesn't radiate as long as it remains in one energy level.